Okay, guys, we are looking at section 4.4 in our student journal. This is on page 93. So our goal with this section is to be able to factor polynomials, and in fact, I want to put a word after that. I'm going to say completely, because we want to have them completely factored. You don't need to write down these definitions, just listen. So, in order to have something factored completely, this is when a polynomial is written as a product of unfactorable polynomials. So if I start factoring something and I have something that can be factored further, then it is not factored completely. Okay? This is pretty intuitive. You don't need to write it down. Factor by grouping. We use this when there are pairs of terms that have a common monomial factor. That sounds a little complicated, but this factoring by grouping, it's going to happen when we have 4 terms. And then we're going to put them into pairs, and we're going to go further with it. The last type we're going to be looking at is when we have something that's quadratic in form. We have AU squared plus BU plus C. So instead of having x's, we have something that's like a u value. So what we mean by this is we might have something like x to the 4th plus 3x squared minus 10. When you first look at that, you think, well, that's not a quadratic. But it actually is a quadratic. If I think of this as u being x squared, I think of u as being x squared, then what would this be? If u is x squared, what do I do to x squared to get x to the 4th?
U squared.
This would be u squared, wouldn't it? So this is u squared plus, and then this is u. And then this is something that we could now factor pretty easily. So I would just set it up. I do u and u. What are numbers that multiply to be 10 and subtract to be 3? 5 and 2. What about the signs? Positive and negative, plus, minus. And then, but then we have to remember, we're really not trying to factor this in terms of u. We're trying to do it with x squared. So instead of using u, we have to go back to the x squared. So when we see something like this, we should just recognize that this truly can be thought of as something that's in quadratic form, even though this isn't to the 2nd power. Another thing we're going to be looking at is completely new to you, and that is how to factor the sum or the difference of 2 cubes. They give us 2 formulas for this. Look at the formula. A cubed plus B cubed. It goes A plus B. Then we square the A, we change that sign, we multiply A and B, and we square the B value. When we're doing the difference of 2 cubes, it's going to be A minus B. We square the A, we change that sign, and this is going to be a plus. What do you notice about this and the original and this and the original? They are what? They're the same, aren't they? See how this is the same as that and this is the same as that? This sign, though, is the opposite. This sign is the opposite. And then notice how this is always a positive. So let's look at how it works in this example. Do you know your cubes? Can you tell me what 1 times 1 times 1 is? Obviously. What's 2 cubed? What's 3 cubed? What's 4 cubed? 64. 5 cubed? 10 cubed? Those are the common cubes we're going to see. So in this case then, if this has to be a cubed, what's a in this case? No. What's the cube root? It's 4x, isn't it? And then our b value, what's the cube root of 1? So here would be a, here would be b. So look at what they did when they factored it. They did a plus b, and then it's a squared minus a times b, and then plus b squared. See how they're just using that formula? Okay, over here, they're going to use this formula. What's the cube root of 27? So A is going to be 3x. What's the cube root of 8? So B is going to be 2. Now we apply the formula. It goes A minus B. It goes A has to get squared plus A times B plus B squared. Okay? Now, to me, instead of memorizing two formulas, I just like to think of it as one formula. Look at this. This is saying if I have a plus, I'm going to use a plus minus plus. So if I have subtraction, what are we going to do? Subtraction, then addition, and then addition. Do you see what that's saying? I can do plus, plus. When this is addition, this is addition, this is subtraction and addition. If it's subtraction, then it goes subtraction, addition, addition. So I just always think of this one formula. All right, let's try just using this one formula. Here's our first problem. You don't have it on your paper, so you're going to want to write it down. 1000x cubed plus 27. Kieran, what's A going to be?
10x.
Good. Kat, what about B? Okay, so now we're going to have to apply the formula. So let's try doing it. So it's going to go A, and then the signs match. I'm using the plus, so A plus B, and then I have to do A squared. So what's A squared? 100x squared, good. Then I look at the formula, and now I have to go to subtraction. So when it's addition, I have to go plus, minus. So this is minus. And then I have to multiply A and B. And then I have to do plus B squared. And here's something to keep in mind. This part right here will never factor further. Unless you didn't factor out a GCF. But if you've done the factoring correctly by first looking for a GCF, that will never factor further. You won't even have to check it. Because sometimes you look at this and you're like, yeah, but couldn't that go down to like 10x minus 3 times 10x minus 3? It's not going to work. That would end up being 100x squared minus 60x plus 9. All right, I want you guys to try this one now on your own. 8x cubed minus 125y to the 6th. Marcella, what did you get?
2x minus 5y squared times 4x squared plus 10xy squared plus 5y squared.
Do we agree? You should. That's correct. Did anyone need help with that? Okay, let's go over to the next page. Since it's a block day, we have 2 days worth of notes, but we're going to come back to this here in just a minute. So let's go down here with some more factoring. The first thing, number one thing you have to look for is a greatest common factor. You must look for that first. It makes factoring so much easier. So in number one, we have 20x cubed minus 220x squared plus 600x. I look at 20, 220, 600. What can they all be divided by? 20. What power of x could I factor out? Just x to the first. So now I do that division. 20x cubed divided by 20x is x squared. 220 divided by 20 is 11. 600 divided by 20 is what? 30. So now I have to check to see if I can do more factoring. Well, it looks like I can, because are there numbers that multiply to be 30 and add to be 11? Yeah, what are they? 6 and 5, so I need to go further. Remember, we want to factor completely. So I do x and x, 6 and 5 is what you told me. I want the outers and the inners to give me a negative 11x, so what do I need the signs to be? Both are subtraction. There we go. Easy enough. All right, let's check number 2 out. What can I factor out? Look for that GCF first. M. I have m to the 4th minus 81 now. I still have this m. Now, this is called the difference of two squares. When I have two terms, I'm always going to be looking for that difference of two squares. So this is going to go down to m squared plus 9 and m squared minus 9. Were some of you thinking of that? That it was the difference of two squares? Hopefully you were. That's difference of two squares is this. So that's what we're doing. Now I have to make sure I'm completely factored. This can't factor further, and the sum of two squares does not factor further. I can't do that. But can this go down further? Is it the difference, the subtraction of two perfect squares? Yes, it is. So I just bring this one down. It doesn't change. This one I can't do anything with. But the difference of two squares, that goes down to m plus 3m minus 3. And that's because when I check those outers and inners, I have a negative 3m and a positive 3m, so that m term is gone, and we needed it to be gone. We could never make that happen when it's addition. That's our final completely factored answer. Okay, number 3. Look at the type. This is the sum of two, not squares, but what? Cubes, right. Try it on your own now. Let's go. Ethan, do you have it?
Yeah.
What is it?
It's going to be, it's going to be 3a plus 2b, and then that's multiplied by 9a squared minus 6ab plus 4b.
Perfect. Okay. All right, let's.
Why is it minus 6ab?
Because in your formula, if you look back at your formula, if we have plus, then it goes positive here, minus here, plus. All right, let's take a look at number 4. Here's something you have to know, that when you have 4 terms, you're going to look for this grouping in pairs. So I've got these 4 terms. I'm going to break them up into pairs. I'm looking at this pair, and I'm looking at this pair. So I want to think, what can I factor out of 5t to the 6th plus 2t to the 5th? What's the GCF for these two only? 2t to the 5th, right. So I factor that out. I'm sorry, not 2 though. Just t to the 5th. So if I do 5t to the 6th divided by t to the 5th, that's going to be just 5t. Plus, I have 2t to the 5th divided by t to the 5th, that's just plus 2. Out of these second two, I have to look at what I can factor out, and what would it be? T to the 3rd. You also always want to factor out that sign. So I want to factor out a negative t cubed. Always factor out that sign. We'll put a little star there so you remember that. So I have to do negative 5t to the 4th divided by negative t cubed. That's going to be 5t. Negative 2t cubed divided by negative t cubed, that's positive 2. So now I have two terms. I have this term and I have this term. What do those two terms now have in common? Karen?
5t plus 2.
So I'm going to factor out a 5t plus 2. When I look at this and I factor out a 5t plus 2, I'm left with t to the 5th. Oh boy. When I look at this and I factor out a 5t plus 2, I'm left with negative t to the 3rd. Now, look at this though. What's the problem here? Do these have a common factor?
Yes.
What's the common factor there?
T to the 3rd.
So I would now have to factor a t to the 3rd out of that. So I'm going to have a 5t plus 2, and out of here I'm going to factor out a t cubed, and I'm left with t squared minus 1. Why did that happen? Why did I end up with something where I had to factor this t to the 3rd out? What did we forget to do at the very beginning? Look for a greatest common factor at the very beginning. Can you see how there would be a t to the 3rd at the very beginning? Okay? And we are still not finished with this problem. So we have a 5t plus 2. The t cubed I'm going to put out in front. And then what's this going to be? The difference of 2 squares. So what's it go down to? Right. And so this would be my final complete factorization. Here's what I like to check. T cubed times t's to the 4th, to the 5th, to the 6th. I need to have t to the 6th. I want to make sure I didn't forget anything, and we didn't. So because we forgot to check that GCF, we had to factor out a GCF out of here, which made it a little bit tougher. So you might want to make sure that you do that at the beginning. All right, let's try number 6. At the very beginning, let's remember to look for that GCF. What's the GCF? 5. Now it's going to be easier to do. I didn't mean to group them yet. Hold on. Okay, so I just factored a 5 out of the whole thing. So I have to remember to bring this 5 down. I'm going to group. I'm going to go 2 and 2. Okay, what can I factor out of these two, you guys? P. So I'm going to have a P out of those. And then I'm going to be left with P squared plus 1. What can I factor out of these two? Nothing really, but I have to factor out something. So remember how I said you have to factor out this sign? So what am I going to take out then? A negative just 1, right? So negative p squared divided by negative 1 is p squared. Negative 1 divided by negative 1 is plus 1. So now I just bring this 5 down. I look at this and this. What do those two have in common? Right, so I'm going to factor out a p squared plus 1, and then when I take a p squared plus 1 out of here, I'm just left with a p. When I take the p squared plus 1 out of here, I'm left with minus 1. So this would be the way that it factors. Yeah, Carter?
Why isn't the p squared plus 1 one of the, what's
The special difference of two squares? Because of the word difference. What does difference mean? Subtraction. Is that subtraction? Right. Okay, any questions? Those are kind of tough, those grouping ones, but you can do it. All right, let's go over here. This is one of those that's quadratic in form. All right, so I'm going to set up my double parentheses. So I look here first. What times what is y to the 4th? Right, and these have to match, guys. And basically, it's always going to be whatever's here. That's what we're going to put there. Now we look here. What are numbers that multiply to be 48? 6 and 8. But will 6 and 8 give me 13 when I add them or subtract them? No. They need to subtract to be 13. Some people are saying it. What is it?
16.
Yep, 16 and 3. Here's how you can do this, guys. If you don't know, write out the factors. I can use 2 times 4 times 2. That's 8 times 3. 8 times 3 is also 48. I'm sorry, 16 times 3 is also 48. What I'm doing is I'm multiplying all of these together. 16 times 3 is 48. So I'm going to use my 16 and my 3. Which one's negative? And then can this factor down further? Yep. Difference of two squares. All right. Do you feel pretty comfortable about all the different ways to factor? Yeah, Karen.
So for that one, could you pull out the y squared and just say y squared 3 minus 16 or negative 16 plus 3?
Say that again.
So say you pull out the y squared.
Yeah, but this doesn't have a y squared. Are
No,
you?
no, on the second step.
Okay.
So there's a y squared in both of them.
Yeah, but it's not a factor. It's a term.
Oh,
Do you see the difference?
yeah.
Like, if it had been y squared, negative 16y squared plus 3y squared,
Okay.
then you could, but not here. This is like a factor, and that's a term within the factor.
All right.
Okay, so there are tons of these we could practice, but I feel like we have the hang of it, if you guys do. Maybe we'll come back and do one in a minute. Let's do something a little bit different, though. Let's do the second part. This is my favorite part here. It says, determine whether the binomial is a factor of the polynomial. We're back on page 94. This is not in your book, but just watch. So the question is, determine whether the binomial is a factor of the polynomial. The binomial we're given is x minus 2. We want to know, is it a factor of x cubed plus 3x minus 6? In order to answer that question, we have to know this rule. This is very important. This is in your book. You have to know a polynomial has a factor of x minus k if and only if f of k equals 0. That means if we plug in k into the function and we get 0, it's a factor. Okay, so we want to know, is this a factor? What's the k value here? 2, right? 2 is the factor, x minus 2. So 2 is the value of k. How can I quickly check to see if plugging in 2 would give me 0? I could literally plug it in, right? But what's the new way we learned? Synthetic division, so I can put 2 in the box. Use my coefficients. 1, 0, 3, -6. I bring this down. That's 1. 2 times 1 is 2, add. 2 times 2 is 4, add. 2 times 7 is 14, add. Am I going to get 0? So is it a factor? No, not a factor. Okay? So that's what we can quickly tell. Okay, let's look at this example. Show that the binomial is a factor of the polynomial. Then factor the polynomial completely. So they are telling us, in this case, that this is a factor. And by the way, this should be x cubed. So this is a factor. What's our k value here, guys? It's not 2, -2. So -2 goes in the box. This should be x cubed plus 2x squared minus 9x minus 18. Use the coefficients. 1, 2, -9, -18. Bring this down. Add. Multiply. Add. Multiply. Add. Did we get 0? Yes? So what does that mean? It's a factor, right? It better be, because didn't it say to show that it is a factor? So it should be. Okay, so now look at what we're left with. Remember, this is our remainder. This is our constant term. This is our x term. And this is our x squared term. So what are we left with then, guys? X squared minus 9. We're supposed to completely factor this. How does x squared minus 9 factor? But we're supposed to do the complete factorization of s of x. So we know it's x plus 3, x minus 3, but that's only x squared and I'm supposed to have x cubed. What am I missing for that complete factorization? What's the other factor have to be? They gave it to us, guys. What's the other factor they told us? X plus 2 is the other factor, right? Because I have to have x times x times x is x cubed. So now I know I have all the factors. These are all of the factors. Guys, look at this for a minute. This is the best problem. I love this problem. How can I factor this using the method we just learned? What do we do when we have 4 terms?
Pair them.
Pair them. So I'm going to pair these two. I'm going to pair these two. What can I factor out here?
X squared.
What am I left with?
2 x.
What do I factor out of here?
3 negative.
What am I left with? X plus 2, right? Okay, so now I look here. What do they have in common? And then what am I left with? So I have x plus 2 times x plus 3 times x minus 3. Isn't that the same thing we got? See? All this stuff should be related. So I could have found all my factors just by factoring it by grouping. But we were told one of the factors, so we used synthetic division. Then we looked at what we had left and we just kept factoring. Okay? That's a really nice way to do it. Okay, we're going to go over here to page 95. Page 95. We're going to do number 17 together. Then you're going to work with your partners on 15 and 16. Here's my function. Here's my factor. I have to prove. Look at the directions. Show that the binomial is a factor of the polynomial. Then factor the function completely. What goes in the box? 5. Use your coefficients. 2, -12, 6, 20, And what am I going to use for my last coefficient? 0, good. So I have to bring this down. I multiply, add, I multiply, add, multiply, add, multiply, add. I have to make sure I get a remainder of 0. That tells me it is a factor. This was my remainder. This is my constant. This is my x. This is my x squared. This is my x cubed. So what I'm left with then is 2x cubed minus 2x squared minus 4x. I'm supposed to factor it completely. I already have one of my factors. I have to find 3 more factors. What can I do here to factor this? What do I always look for first? GCF. Take out a 2x. We're left with x squared minus x minus 2. So the 2x stays. How does this factor? X minus 2 times x plus 1. Look at this. This is x times x squared, x cubed. I need to have x to the 4th. What's the missing factor? X minus 5. And so this is how that whole factor, or I'm sorry, that whole polynomial, that's how it would factor right there. I check again, x squared, x cubed, x to the 4th, I got them all. Okay, you guys go back now and try number 15. Check your answer up here. Do they have to be in this order, you guys? No, they can be in any order. It's multiplication. Yes, Karen?
Where do you find out the... Oh, okay, never mind.
Anybody else questions? All right, just to save a little time, I want us to go over to this last problem. This is not in your student journal, but I just want you to watch. Later on, we're all going to do a roller coaster project. You're going to work with your group. You're going to come up with a polynomial function to represent a roller coaster. So this is kind of like a preliminary thing that will help you to start thinking about what you might want to do. So this is a real-life application. It says during the first 5 seconds of a roller coaster ride, the function h of t equals this represents the height in feet of the roller coaster after t seconds. How long is the roller coaster at or below ground level in the first 5 seconds? So here's our time axis, here's our height axis. So it's asking us how long it's below, at or below ground level. Where would those points be when it goes below? Karen?
Well, the ground level would be 0.
Right, so right here's ground level.
Yeah.
So we're talking about between here and here, right? That's where it's below ground level. So maybe there's some safety concerns. Maybe they don't want people below ground level, more than 5 seconds or 4 seconds or something. So we want to check this and see how long that is. How can I figure that out? Do I know what this value is here? How many seconds that is? 2 seconds, right? I can just see that. How can I find out what this point is exactly? I can't do it unless I have a calculator. This is called a zero. So I'm going to go to my calculator. You guys do this too. So I have it in my calculator. I do a zoom 6. Here's the way it looks. I don't like the way this looks. It doesn't look the way theirs does. I want it to look the way theirs looks. So I'm going to go to my window. Theirs x's or their t's are going from -2 to 6, it looks like. -2 to 6. Their y's are going by 20s. So they're going from like oops, not that. They're going from -20 up to, looks like 100. So now when I hit graph, I like the way this looks better. Oh, it's still not quite low enough. Let me make it go down to like -40 or 50. Okay, so this is good. So I want to know when it's below ground level. I know that's at 2. How am I going to find exactly what that is? It's not a y-intercept, it's a x-intercept. I'm going to go to y equals, and what do I want the height or the y to be? 0, so I'm going to put in 0. And so now I just want to find that point of intersection. So second trace, calculate, intersect, get over there close to it. I don't want it to find 2 again. Enter, 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 and it is 4.25. So how long then is it at or below ground level? 2.25 seconds. All right, let's think about these now with our groups. What is the height when the ride begins? Right there's the height when it begins. How would I find that height? Somebody besides Karen.
Why not?
Because you've answered about 10 questions. Can somebody tell me? What's it going to be, Jacob? Or Zachary, I mean. Yep, it's going to be equal to this constant, isn't it? Because I'm going to plug in 0 for t, and then I'm going to get my y value. So this is going to be what then? 34 seconds? No, 34 what? Feet. Okay, what is the lowest point that the roller coaster goes? Well, I can see it right there. I can see it right there. Would you guys know how to find it? All right, Karen, how would we find it?
Trace minimum.
Okay, so I go second trace, find the minimum. I'm going to go to the left of it because it says left bound. I think it'll work. Go to the right of it. So the lowest point it goes is negative 21.258. 21.258 feet. That's the lowest it goes. What's the coaster's height at 5 seconds? Somebody tell me how I could find that. What could we do, Ethan?
Could you go to the table and then find when x equals 5?
Awesome. So we go here, look at the table. When x is 5, 54 feet. Last question. Think about this. Why do you think this is not accurate for the entire time the coaster is traveling? Marcella.
Because it starts in a minute and later than 30 years.
Right. Here, it's starting way down here, but that's actually before they really get on it. But here, look at this. If you're on it for like 8 seconds, it's going up to infinity. It's never coming back down. I don't want to ride that thing. It's never coming back down, so that's no fun. So that's why it's only going to be accurate for 5 seconds. So guys, this is what you're going to have to do. You're going to have to create a polynomial function for your roller coaster, so you better make sure it comes back down, right? Or you're not going to get very many people wanting to go on it. It looked pretty cool, but kind of reminds me of Jack and the Beanstalk. You know how you like just keeps climbing? I don't know. Okay, so we've got our homework assignment.